In this video, we are going to talk about determining the net spring constant of springs arranged in series. Now, before we start, if you are new here, please take a second or two, then subscribe, like, and share the video. Now, if you don't know how springs can be arranged in series arrangement, I have a sample here. So this is the sample of how springs are arranged in series. This is spring 1 arranged back to back to spring 2 so that they act on one mass. So the force exerted by spring 1 on spring 2 is equal to the force exerted by spring 2 on spring 1. So that we can write it F1, force 1, is equals to force 2. And force 1 is given as K1 multiplied by X1, then equals to force 2 is written as K2 multiplied by X2. Now, after writing it like this, so we shall have to divide both sides by K1 so that we have X1 equal to K2 multiplied by X2 divided by K1. Now, after writing it like that, how can we now determine the total extension? The total extension X is given by X1, the extension in spring 1, added to extension in spring 2. And here we have the new format of writing X1. So we can substitute here X is equals to extension 1, which is K2X2 divided by K1 plus X2. This is now the total extension. Now, this can be written as, you realize that we have X2 here and X2 here. So, we can write X2 in brackets K2 divided by K1 plus 1. So that when you multiply X2 multiplied by K2 over K1, you shall get this. Then X2 multiplied by 1, you shall get X2. So this is equals to X. Now, after writing it like this, X is equals to X2 in brackets K2 divided by K1 plus 1. Now, you can realize that we can now choose to remain with X2 as the subject of our formula. So that X2 can be given as X, this X, divided by the whole of this now, K2 divided by K1 plus 1. Now, after writing it like that, this denominator can be written in a different format also, so that it is also true to say X2 is equals to now X divided by K2 in brackets 1 all over K1. So that when you multiply K2 multiplied by 1 over K, you shall get K2 divided by K1. So plus this one can also be written as K2 divided by K2. So that this K2 shall cancel out with K2, we remain with 1. So we can write 1 as 1 all over K2. So that when we multiply K2 times 1, you shall get K2 divided by K2, you shall cancel out to get back to this. So this is now our new format of writing K2 divided by K1 plus 1. Now, after writing it like this, you realize that we want to determine force. Force 2 is given as K2 multiplied by X2. So here we have X2, but we don't have, one thing that we need to have to arrive at force is K2. Now, force is equals to K2 multiplied by X, multiplied by this X now, divided by our denominator is now K2 in brackets 1 over K1 plus 1 over K2. After writing it like that, this is now force. Then you realize that we can cancel out some items here. This K2 can cancel out with that, so that we can have F is given as X divided by 1 all over K1 plus 1 all over K2. This is now our force. And you realize that we need to have the net spring constant. Spring constant K is given as F divided by extension X. So this is, the whole of this is F. So we need to divide it by X so that we can arrive at K. So we take X divided by 1 all over K1 plus 1 all over K2. Then we divide it by, we need to have K, you divide it by X, so that this is now our spring constant. So this X shall cancel out with this X, so that we can have here K is given by, now after cancelling out X by X with X, so here we are left with 1. So this is 1 all over, now 1 all over K1 plus 1 all over K2. Now this is now our spring constant. So you can write this K change it in reciprocal form, so that we can have 1 all over K is equal to, now the inverse of this is given as 1 all over K1 plus 1 all over K2. Now this becomes now our net spring constant. This is the net spring constant gotten by adding the reciprocal of spring constant 1 plus the reciprocal of spring constant 2. Thank you.